I'll go ahead and jump in and get started then. Let me scroll back to the start of my presentation. Oh, and before I forget, I've got some cards here. I'm going to hand these out. These actually have like this is audience participation. You guys are going to help me do this presentation. So take these and hand them out. There's an address on there. There's a QR code if you want to scan it with your phone. And we're going to use data that you guys generate in order to generate the SVGs that we see on the screen. OK, so we're going to talk about D3 and SVGs. So who am I? My name is Micah. You can follow me on Twitter. I'm a Ruby on Rails web developer, sort of full stack. Do a lot of JavaScript as well, obviously. And I co-run a Ruby on Rails consultancy called the Agile League, and we're based in Atlanta. I'm also really into board games. And I was going to say, if you don't like it, I actually have a board game here. So if you find several people that don't like it, it's a short board game, too. You could probably, if you start soon, you could probably finish for the next talk. So what is Smiler? So Smiler is this application that I built that I'm having you guys log into that is basically just a little test app to show what we can do for D3 and SVGs. It's also kind of brittle. I didn't make it fully secure, so if any of you guys are hackers and you've got your laptop, well, he does. So if you drop into like the Chrome debugger, you can break this thing very quickly, so please don't. So go ahead and get logged in, and we'll go ahead and prime the pump because it's based on data, and the data is upvotes, downvotes, like what you guys think. If you like the presentation, there's like an upvote button. If you don't like it, there's a downvote button. If you liked lunch, upvote, just whatever you're feeling at that moment, just start clicking away. So has anybody been able to log in yet? Get access to it? And there's some cards floating around that have like a QR code on it. Did anybody actually use the QR code? Sometimes it doesn't. Did it work? OK. Sometimes it doesn't work because the there we go. There you see. Look. There's a. So yeah, let's see if people are getting in. Yeah, there we go. There's our heartbeats. Somebody managed to log in. That usually ends this presentation very quickly if no one can get in. All right, so let's prime the pump. Let's get some data in there. So vote based on what you think of the following things, like how they make you feel. I hope this makes you feel good. I hope we all like kittens. I assume none of us like paying for parking, so we'll give some downvotes there. Car crashes. I assume you don't like those. Maybe some of you run an auto body shop, so maybe you like these. We all like puppies, but not those. Some of us probably like this guy, so we'll probably get some upvotes here, which will probably be the opposite of people that like this guy. So some upvotes here as well. And we all like puppies, so we'll end on a high note. So we should have some data. Our pump should be primed at this point. We should have some data in there. What kind of data do we have? Well, it's a big array of votes. Like basically all I'm tracking is when you voted, whether you voted up or down. It's a score of 1 or -1, and who you are. So just basic information like who voted, what did they vote, and when did it happen. So that's great. Now I've got data. I've got data in the system, but the whole point is I want to visualize that data in some way. I want to display that data. So how do we want to visualize it? Well, when you have data, the basic answer for visualizing it is charts. And in the JavaScript world, you can go out there and get any number of charting libraries. There's things like high charts, and there's actually several charting libraries that are built on top of D3, things like NVD3. And they're nice. They're great for visualizing data if you want to create a chart that is sort of like your off-the-shelf chart. Like I want to make a line chart. I want to make a column chart. I want to make it look like Google Analytics or Johnny's boring business presentation. So if you want to do that kind of stuff, you go out and you grab one of these charting libraries. They're very, very easy to use. You dump your data in, and you get one of these sort of off-the-shelf, predefined charts. It's great. It's a great way to do it. It's a great way to visualize your data. But it's boring. It's not cool. So we want to display things in a cool way. So that's where D3 comes in. So D3, charts are the boring answer. D3 is the fun answer. But it requires a little more tech savviness on your part. Some assembly required. I was asked this. I don't actually mean assembly code. You still get to write it all in JavaScript. No need for actual assembly code. So D3 stands for data-driven documents, and it's all about getting your data into a format and marrying it to the DOM, the document object model, the representation of what the browser understands for a web page, sort of behind the scenes. All right, so let's see. Where are we at? Heartbeat check. Yeah, we're still getting votes. Yep, they're coming in. So you guys are still awake out there. And before I forget, if anybody ever has any questions, this is a small group. I like to be interactive. If you have any questions, don't even raise your hand, just ask. Or raise your hand, I'll call on you right away, but it doesn't matter. So, all right, so we want to marry our data to the DOM. We've got this large array of votes, and we want to actually turn it into something to display. So what D3 allows us to do is it allows us to map arrays onto the DOM without iterating. So normally if you have like a large array of votes, you're going to say, like, you're going to make a for loop, and you're just going to say, all right, for this element, draw this thing. You know, for each item in this array, draw these things. So that's a very traditional way of doing programming. With D3, it's declarative. And what that means is instead of telling it, you know, iterating through this array and doing all this stuff, you sort of take an example of one element and you say, given this example, we're going to zoom in on one thing, and given this one example of this one thing, I'm going to tell you what to do with it, and then you expand on that. D3 is going to magically handle the rest and take the rest of your array elements and do what you tell it to do based on what you told it to do with that one element. So it takes a little bit to wrap your head around if you're used to the traditional programming style, but it's very nice. So here's our classic D3 example of building a table with these votes that we have. And so at the top, what we do is we select the table itself using sort of traditional CSS-style selectors. If you use jQuery or selector API stuff in the browser, you select the table, and then you say, select all table rows. And each table row, in our case, is going to represent one array, or one vote. One vote is represented by a table row. So you select all those table rows, then you call data, and you inject, you know, in this case, don't even worry too much about what the array looks like. So you inject the data in there. Enter is something that we'll get to in a second. And then you append a table row. And so what you're saying is basically you're telling D3, for every element in my array, I want you to make me a table row. And you'll notice there's no iteration here. I'm not actually iterating over the array of votes at any point. I'm just saying, like, here's my votes. And when you start messing with this D3, please make me a table row for each element in this array. Now, so in so we've got our row that represents one vote, but we need our columns in that row to represent the data of that vote. So this part up here where we're appending a TD, we are putting an image that is the user's picture. So we're adding the user's picture to it. In the second one, we're adding an image to show whether it's a thumbs up or a thumbs down, an upvote or a downvote. And then down here, we're just setting a timestamp to show when it occurred. So the point is, I don't actually ever iterate over the array. Instead, I'm basically telling it in a singular case. So in one particular case, I want you to make a row and then make individual data elements for that row. So what does that look like? So let's look at our vote list. So yeah. So here are voters. I mean, here's as someone comes in. I never actually iterate to generate this array and showing these people. Instead, it's just they are like, I tell it, here's what you do in a singular case, and then it will expand upon that to generate, somebody didn't like it. Not happy. So very unhappy.
At the bottom is left side good, right side bad?
Yeah. On the mobile app, you can't see the up and down arrows.
Yeah, we sized it wrong on the mobile app, so anyways, you'll figure it out. So I'm basically telling it what to do in a singular case, and D3 figures out all the rest. It's very nice. It's a very nice way of structuring your program. And now, I said I would get to what enter means in a second, and that's what I'll get to here. D3 is built to work with data that changes as you go on. And so it allows you to build these visualizations that animate and restructure themselves and change based on the underlying data changing. And the way that it handles that is with these phases, this enter phase, an update phase, and an exit phase. And so in the beginning, so with our votes, what happens in the beginning is we hand we hand D3 an array of votes that it's never seen before, and then we call enter on that, and it's going to go through, and everything is new. So it's going to take everything in there, and it's going to make a new table row for each one of those. as things change, as more votes come in, I'm handing the data back to D3 periodically saying, like, here's the data again, run it again. Here's some more data, run it again. D3 is smart enough, and again, so I'm not iterating over the data. I don't have to go through and figure out, here's my new elements, here's the stuff that's changed, all this other stuff. D3 does that on its own. So I just keep handing it the data as it comes in, you know, here, you figure it out. You figure it out. And it runs through these 3 different phases. The enter phase is what it will do when it sees data that's new. And so in our case, when it sees data that's new, it's going to make a new table row, and it's going to add all those elements into it. The update phase is what it does. It'll run through that when it sees data that it's seen before and, you know, potentially has changed. Like, and in our case, I'll get to in a second what we do in our case. Exit is what it does when it looks at the data that you send it, and it says, wait a minute, the last time I saw this data, there was something here, now it's gone. And so in most cases, what you're going to want to do in those places is make something disappear. You know, pull it out of the DOM, make something fade away, make it slide off the side of the screen, these sorts of things. So that's our 3 phases, and they're very powerful. And so you think in terms of your data, like, you don't have to track what changes. You don't have to track what's new. You just think of it in a very momentary, like, this is what I care about right now, and D3 handles everything else. Very nice stuff. Oh, and I will praise D3 a lot. I should be very clear. I didn't write it, so I'm not praising myself over here. Like, when I say it's clever and smart and nice, it's because somebody else was clever and smart and nice. So this is a dynamic table. This is our sort of same table example, but instead of just having the enter phase, now we've got all 3 phases. And so what I'm doing here first is the exit phase. And in that case, all I say is I set opacity to 0. It's going to fade out. Things are just going to disappear when they're no longer in the array. In the update phase, all I'm doing is I'm changing the timestamp. Because the timestamp that I'm showing on that shows, like, this was an upvote from 5 seconds ago, 3 minutes ago, that kind of stuff. The thing is, at the first moment when the hand is shown, it'll always say a few seconds ago because it happened very soon. But as things are being updated, it's redrawing and it's updating those individual DOM elements to say, like, all right, now it happened 2 minutes ago. As the votes get older, it's updating them over time, if that makes any sense. And then the enter section is the same as it was before. So this is a fairly common way that you'll see things work. The enter section is very big in where you're defining everything that happens on a new element, and this is the whole structure that I want to build. Update is very small, and that is, like, as the data changes, here's the small changes that I want to make to my HTML structure as the data changes. And then exit almost always is like, all right, pull this thing out. It's no longer in my data, so the simplest one is just rip it out of the DOM instantly, and other ones are, make it fade out nicely or, slide away, that sort of stuff. And so it's called joins. These it's hard to explain. Anyways, it's sort of a strange syntax because, especially on the enter phase, because you select the table, and then you have to say select all of the elements that you're going to be using, the elements that you're going to be putting in there. In our case, it's rows, TR elements. So you say select all rows. But in the beginning, there are no rows. And so it's very strange, because you're like, all right, I'm selecting all rows, but there are no rows. Then I'm doing this data. Then I'm entering. Then I'm appending rows. It took me a long time to wrap my head around it. And you'll see this a lot. And if you're new to D3, it can be very confusing. Because you're thinking like a programmer that's like, all right, select all rows. There are no rows. But it's more that you're saying, like, I'm declaring that rows are what I care about. It's sort of a way to think about it. So anyways, the point of this slide is it looks weird at first. Just you won't understand it at first. Just follow the examples in the tutorials and copy what they do, and you'll get it later. That's the point. You don't need to understand on day one exactly why the things look like this way. All right, so we're using D3 to build tables. All right, get your bingo cards out. I put this one in just for the bingo cards. There was supposed to be a Star Wars thing in the presentation. So yeah, using D3 to build tables is like using the Death Star to shoot down an X-wing. Like, you can probably do it, but there's much easier ways to do this. So we don't really care about making tables. We want to make cool stuff. We want to make cool shapes, images, all that kind of stuff. And so to do that, we're going to use SVGs, Scalable Vector Graphics. Also happens to be the name of some company, I think they're in Britain, the Sports Video Group. So they unfortunately chose their initials to match something that's very popular in the computer world, and they're probably wondering why they get a lot of emails that are like, hey, how do I make circles? And these guys are like, we do video. And for the extra nerdy of you, this was the image I found of their logo, and it's a JPEG. And I just thought, if only there were a format for holding line art like logos that you could use on the web, but apparently not. So JPEGs are the best we can do. All right, so we're dealing with SVGs. And SVGs are all about shapes. They're all about drawing things on some sort of virtual canvas. And so we're going to deal with the primitives. And the primitives are things like rectangles, circles, ellipses, lines. And then there's paths. Paths are the ultimate primitives. And you can think of a path as just a long string, sort of a numerical description of a pencil moving around on a canvas. And it's things like pick pencil up, move over here, put pencil down, draw a curve, pick up, move, put down, draw a line, draw other line, connect back to original point. And so it's a long, if you actually look at one, they're unintelligible. You can't figure out what they do. You run them through the computer, and the computer just draws what it's told to draw, and you've got a shape. So for the most part, you're dealing with like the more advanced primitives, things like rectangles and circles. But when you need to drop down to it, you can draw these real complicated paths. And D3 has some help, gives you a lot of help to do that. So when working with scalable vector graphics, I'd say follow the spec. Like this is the W3C page describing the specification for SVGs. And I don't know about you guys, but if I ever find myself on a W3C page, I'm instantly gone. Like they're just not helpful. They're like, here's some eBNF notation description of this syntax for this particular header, and I'm like, I'm out. So, but it's actually very helpful for SVGs. And so when I'm working on doing any of these displays or anything like that, I have this open the whole time. Like the W3 spec is actually the best help that I've found for like technical documentation on how to use the primitives. You'll find a lot of tutorials on like how to use SVGs, but this is like the actual specification is very good. So, all right, so back to our particular problem. We've got our array of votes, and we want to draw shapes now. We don't want to do table elements. We want to draw shapes. So, like I said, we're dealing with these shapes, and these shapes are defined by sort of x, y coordinates. Go here, that's the center point of a circle. Go x, y over here, then, circle of radius this, then draw a circle. So we need these coordinates. We need this coordinate information. How do we get that from the data that we have? So the data we have is just a bunch of votes. Well, the solution is scales. And this is a really simple concept. I'm going to over-explain it. I'm going to make it sound a lot more complicated than it is. It's basically just a way to take data that you have in your sort of data domain that you're in and translate it into a different data domain. In our case, it's going to be things like pixel width, x, y coordinates. I want a bar. I've got a space for this visualization that's 100 pixels wide or 100 pixels tall, and I've got my data. In this case, it's world population data. So I'm dealing with numbers like 2 billion and 4 billion and 6 billion, but I need to translate those to 40 pixels and 16 pixels and these sorts of things. So D3 gives us this concept of scales. And so the simplest one is just a linear scale. You give it the domain, and our domain right here goes from 0 to total world population, and our range goes from 0 to 100. So basically what we're doing is we're creating a scale that allows us to express percentage of world population. And you could think of that as if I'm drawing a chart that is 100 pixels high, how tall are my columns in this chart? So take China population. It's like 1.3 billion or something like that. It is going to be 19 pixels high. The US population is 300 million. It's going to be 4.5 pixels high because it's 4.5% of the world population. Like I said, I'm way over-explaining this. It's a very simple concept, but it's very powerful. And so in D3 stuff, you've got your data. You don't have to make these calculations yourself. You get to remain in your domain, your problem domain. If you're thinking about world population, you get to have your data in world population numbers. You don't have to have it in pixel numbers. So you let the scales handle translating everything to the underlying, what the browser understands. So again, it's very nice. D3 helps you stay in your problem domain. Don't drop down into iterating things. Don't figure out pixel widths and all that kind of stuff. Like, just think about world population. Think about country sizes, that sort of stuff. So this is a real example of what we're doing on, where's our user column? That's one of my favorite charts. So yeah, what we're doing here, we've got charts, we've got these people, and they've got bars coming up out of their heads. Come on. Something's wrong here. There we go. Bars are moving. I don't know. Yeah, there we go now. It's just taking a long time to update. But so we've got these bars coming up and down out of people's heads, and I want to think in terms of votes and vote score. Like your score goes from, I'm saying the worst you can dislike me is -10, and the most you can like me is +10. So your value goes from -10 to +10. But on here, I've got these things positioned. This is, some amount of pixels up here and some amount of pixels down there. It's not -10, it's not +10. So I need a scale. Come on. And so this is my scale, and the domain goes from -10 up to +10. And this is actually what's called a polylinear scale, because I got lazy with the drawing of some of this stuff. And what it does is it actually goes from -10 to 0, and then it goes from 0 to 10. And I actually break the scale up into 2 different spots. And then my range goes from 0 to the maximum height of the bar, and it auto-calculates that. I've got some other stuff in there that just auto-calculates what the size of each individual space should be. And I can just calculate that somewhere else, toss that into this scaling function, and let it go from there. And so right here, I'm building a rectangle. That's one of our SVG primitives. So I build a rectangle, and then I set the y attribute. Anyways, the height attribute is the important part, where I call the scale function. Actually, how does this work again? I get lost in a little bit here. I think it's, because I draw it. The rectangles are drawn. You set a point, and they sort of draw them from there down. So like I say, the y point is go over here, go to a certain point down, and then that's where you start. That's your y, and then the height sets it, and it draws from there down. So that's basically what I'm doing here. And the important thing is this score scale right here, where I pass in. I never have to talk in terms of pixels. Like, I never have to say what the y value is to go to. I just say, you figure all this out for me. You've got pixel widths and all this other stuff. I've set up my scale, and I want to talk in terms of like vote score. So go to this point. You figure out where it is. Draw this height. You figure out how high that should be. And it's just based on the value of the votes that I had. Is this making sense? OK, good. I'll keep going. So you'll use scales a lot in D3. And D3 has some very interesting scales. Very, very common one is time, where you have a time value and you want to translate that to some kind of x, y, like all the way from like your standard, like this is page impressions by month. I mean, the months are times, and then the page impressions, So the x values along that represent the time values that are shown at the bottom of it. One of the most interesting ones is value goes to color. D3 actually has some functions that allow you to specify here is one color, here is another color. Now make up some colors in between that for me, and here's my value. So you say go from red to green, so your domain would be 0 to 10, and your range is red to green, and you pass in 6. It can actually try to figure out a color for you between red and green.
Can it do that incrementally, or does it just could you do very red and I'm trying to think how to say this. Is it going to be like a slight gradient between values, or can you do it so it's significant changes between each one?
It sort of depends on what your domain is. Because if your domain is like let's say your domain is 0 to 1, and your values are red to green. If you pass in 0, it's going to be red. If you pass in 1, it's going to be green. And if you pass in 0.3, it's going to be some variation in between there. But it's just based on the values. So if you want it to make big jumps from one. Yeah, exactly. Pass in values that are very extreme on that range. Or you can make these sort of polylinear scales where you're like, I want you to go from red to pink to this. You can sort of set different stepping points along that line and then pass in the values that go through there. It's more advanced stuff, but and if you're really into colors, which I bet a lot of people here are, like designers and stuff, you'd probably be unsatisfied with some of the stuff that it'll come up with you automatically, like the colors that it makes for you automatically. But for a programmer like me, I'm like, they all look the same to me. So, it allows programmers like me to make cool looking things without really being a very good designer. So, So another one is, let's say you're going to be drawing, pie charts or anything circular. You can do values to angles. So if you want to draw an arc or like a pi wedge or anything like that, you can your domain will be world population or vote scores or something like that, and your range will be like 1 pi or 2 pi, radians, all these sorts of things. So it allows you to translate into these sort of angular coordinate systems very easily as well. And then one of the really fun ones is, so the people that are familiar with SVGs, one of the great things about SVGs is they scale up perfectly. So if you have a circle that's like this, and then you scale it up to like this, it's still going to be a perfect circle. It's not going to have jaggies and jagged edges on it. So one of the nice things that you can do with scales is like, OK, I want to grow and shrink things based on this. So like, maybe I would say like, all right, if you give me 1 upvote, I get a little tiny thumbs up. But if I get 10 upvotes, I scale that up based on the number of votes that I have. And so SVGs have this transformation ability where you can specify a transform on it to say, all right, I want to scale you by a certain factor. And so I can just say like, all right, my scale factor is 1. My scale factor runs from 1 to 30, and now here's my domain of 0 to 10 for the vote score, and based on that domain, it's going to pick me a value between 1 and 30, and then I'm going to drop that into like an SVG transformation, and it's going to scale my thumbs up and thumbs down. So, anyways, again, I'm overcomplicating this. It's simple stuff. So, alrighty. So, putting it all together. Why do I call this thing Smiley? That is, hopefully these charts are working. Okay. Yeah, there we go. For some reason, it's not updating right. But so these are all SVGs, and like as people vote, I am adjusting scales. I'm adjusting the well, I'll go through bit by bit. So. And you actually can't see, if you have it on your phone, you might be able to see it. They actually do change color as well. Like the ones that smile turn green, and the ones that frown turn red. So, but let's start with the mouth. The mouth, what it is it's a curve. It's called a quadratic Bezier curve, and you can basically think of it as a straight line. And this is an SVG thing. It's a straight line that you attach a string to, and you pull on it. And so what basically the amount that I pull is a scale. So it's the scale, from the voting scale. As you vote up, I pull more, and as you vote down, I pull more down this way. And so I can just say like the amount of pull that I put on your mouth is a scale that I hand off to D3. I don't compute it myself. D3 does it for me. So, wow, that's one thing. Is there's a scale for the amount of pull that I put on the mouth. The eyes, the eyes are just ellipses. And the width of the eyes is just also based on the voting. Like the more you vote, the wider the eyes are. And as the votes come back, towards 0, they go down. Can you see them turning red? Yeah. He's supposed to stay red, but I don't know why. For some reason, it's not synchronizing right. I'll throw somebody else under the bus for that. So yeah. That's what's going on here. Is like and like you'll also notice this is something I learned. The corners of the mouth actually move up and down like as you smile. In the beginning, I was just actually curving the mouth, but like it would then curve up through your eyeballs. And so these are all just scales that I set up where I say like, okay, at the most extreme smile, the end points of the mouth should be here, and the bottom point, the amount of pull on it should be down here. And at the most extreme end of a frown, the end point should be up here, and the end point, or the pull point should be here. And so you basically set the extremes for this stuff, and then you generate a scale, and D3 will calculate everything in between. And I could make it so that they, that there was incredible amount of gradation. That like, it could go. I got to go from -10 to +10. I could go from -1,000,000 to +1,000,000, and like the smiles just you would never even really you'd be voting forever, and like they would like. So and that would be like one change in the code. Like to do that, to make that change, I would just change my scale. I would just change the scale that I pass into D3. So, any questions? Any thoughts?
I got one. Slightly defense. You get into doing like a cube and that sort of thing. That's all possible as well, right? To kind of rotate 3D shape.
Not really. You're talking sort of like WebGL kind of stuff, which you could possibly do with D3, but I wouldn't necessarily attempt that with SVGs. You could, and it'd be an interesting project. But I think you would probably, if you wanted to do cubes and 3D objects rotating, and those sort, I would look at things like WebGL first. Like this is great for flat 2D. I want circles and squares and things like that. But as soon as you're like, and now I look behind the curtain at the third dimension, then it gets kind of funky. At least I haven't done a lot of like 3D stuff with SVGs. Like, but you probably could do it, and it would be like, but it'd be like advanced math. That's what I was going to ask. Like, how do you figure out the coordinates? I don't know. I don't think I'm supposed to say that as a presenter, but I say that a lot. All right, well, that's a good question. That's a good question. So let's see here. What have I not covered on this? So one thing that's actually kind of interesting is, and this is where D3 really shines, is I actually don't tell it where on the page to put each one of these smiley faces. With a large array of data, you don't necessarily I don't want to position each one of these things. So what I do is D3 has these different layouts, and this one's called a bubble layout. And you can just say, like, all right, I'm going to give you a bunch of stuff in terms of an SVG, and here's my canvas. Here's my, this giant white section here. I tell D3, that's my giant white section. Here's how wide it is. Here's the dimensions for it. And here's a bunch of junk. And D3 will figure out where to position each one of these guys on it and start, and rendering those things. And the way that it does that, and this is what's really nice about SVGs. Each one of these, smiley faces is sort of a self-contained entity. And when you're drawing with SVGs, like, I don't want to think about this guy being at, this eyeball. When I draw this eyeball, I don't want to draw it at 800 pixels. And then I don't want to draw this eyeball at 900 pixels, because all of your calculations would be like, left point equals 800, eyeball equals left point plus 30 pixels, left point equals 900 pixels. I don't want to think about that. I don't want to think about that. It's way too much math calculation. What I want to think about is, I have a face, and the eye is 30 pixels from the left, and then this eye is 20 pixels past that, and I want to talk about my face. I want to draw that in like the one instance. And then I just want to like draw faces on the screen. And so the way that that's done with SVGs is from these transformations where you transpose something. And so I say, like, you can think of this entire area as one canvas, but then you can think of each of these faces as like their own private canvases, their own coordinate spaces. And so what I will do is I will draw a face in its own coordinate space, like 30 pixels this way, 20 pixels, these sorts of things. I will draw it in its own private coordinate space, and then I want to transpose that into the coordinate space of the overall system. And SVGs just support this natively, and D3, through the use of these different layouts, you can just say, like, give me a bubble layout. So here's my individual private canvases, transpose these items out there. So anyways, I'm not explaining it very well, but it's very, there we go. All right, maybe I am explaining it well. I'm getting some smiley faces. So it's just, it's very nice to think in the small term. I'm going to think in terms of one face. I'm not going to think in terms of my entire canvas. And then I'm just going to allow D3 to move things where they need to be. OK. All right. So animation. D3 does some really cool stuff with animation. And this is a much better example of this than what I have. So we're going to go look at that. Oh, come on. So let's think about what we've talked about so far. These are primitives. These are SVG primitives. What are they? They're circles. Circles have like a location, and then they have a radius. And so we're able to visualize a budget based on the size of basically the size of a circle. So it's a very simple visualization. It's very powerful though. But you'll notice those things are like bouncing around. Like, okay. So let's go visualize something else. Yeah, now these guys are moving around. So how does that happen? Well, I actually don't know. You just tell D3, I want these things to move, And then when it runs through its update section, so we say we have our enter and our update and our exit. When it runs through like an update and values change, it will run the animation function. If you guys are familiar with tweening and other animation concepts, like it will create, you can specify different tweening functions, and it will run that function to change the coordinates of it. So it's important to realize it's not hardware accelerated. This is sort of like jQuery style animation, where it's like x equals 10, now x equals 10.2, x equals 10.3. That kind of stuff is running in the background. So it's very non-performant with large data sets. But for this, I mean, let's look at this. There's probably, I don't know, like 300 circles on the screen. You can animate 300 circles, and it's not that big a deal. If it was like 50,000 circles, you would hit one of these things, and you hear the fans go, we'd be done at that point. So, but what it's doing is it's just saying, like, all right, I have this circle, whatever this budget element is here. I have this circle, and here's its center point. Now, when I want to animate it, like, there's a call called transition that you just call like on the update. When you update something, it's like x.update.transition. That's pretty much all it takes. And then you say like, all right, my xy coordinate for the center point of the circle was 6090 over here. Now it's 2020 over here, and it will run an animation tweening function to move it along that line. And it will do that for all of the different elements that are on there. And so you go from having like the screen flash, where circle was here, now circle is here, to having the circle smoothly animating up there and all of your SVG elements. It's very easy. Like, it's incredibly easy. And so like a chart like this, it's more about using your imagination to determine what it is that you want to describe and what it is that you want to show. And then D3 handles a lot of the heavy lifting. Like, I want to use some circles, and I want to use some squares and lines and those sorts of things to describe my data. And then you hand it off to D3, and D3 will actually put them in the DOM and then animate them across the screen. OK. Now, circles and lines and rectangles and all this stuff, they're fun. They're fun to use, and you can make some really cool visualizations with them. But it's also nice if you can use like actual really, really nice line art. Things like thumbs up and thumbs down, things like smiley faces like this, and all sorts of the different line art that you can find out there. Check marks, X marks, like the little disk that means download this thing. So you can find thousands and thousands of that stuff. They are just path definitions. Like these long, what I was saying, like these long strings of defining paths. And they are SVGs, and they can be treated like normal SVGs, meaning you can scale them up, you can scale them down, you can rotate them, you can sort of skew and twist them and all those sorts of things. But the nice thing is, you can just treat them like normal SVGs, the way that we were treating these circles and things like that. So you can sort of hand them off to D3, and let's say you want like superhero faces to represent your data. Like, as the votes come in for Iron Man, Iron Man's face grows, scales up, maybe turns more red. As the votes come in for Batman, like his face grows up, or maybe his mouth gets like angrier and angrier, that kind of stuff. So, so I can't draw. I can't make these things. But there are tons of vector art libraries out there, and this is one that I use called Pictonic. And for like, I think it was $150, I get 2,000 something, like vector art images that I can download as their individual SVGs. And so the example I like to give for this case would be, what if you wanted to make a visualization for birth rates across the world? Like, you've got birth rate data, you've got it from some data source, and you've got birth rate. And let's make it even better. You've got historical birth rate going back like 100 years. There are SVG, there's like open source, easy to find SVG libraries that describe maps. Like if you think about it, a map is just lines drawn on something. So you could get an SVG representation of the world. And then you could also have like one of these little icons of like a baby. And so you've got like an SVG, think of like the little thing like wrapped and the baby face in there. So then you can use like D3 to marry your birth rate information to the DOM to then draw these little baby icons on the country. And then you use scales to transform the size of it. So you scale the baby up for countries that have large birth rates, and then you scale them down for countries that have like lower birth rates. Finally, you connect this to the animation and to your historical data so that like you have like a little thing that runs and updates it over time and just hands it, all right, for 1910 it was, 50,000. For 1920, it was 60,000. And you turn on the animation, you just connect all this stuff up together, and you've got a chart, you've got a display. I hate the word chart. You've got a visualization of the world with babies growing and shrinking, like maybe we see Europe in the 1800s starts growing, and then it starts shrinking, and then like these days Africa is growing, all these countries in Africa. And so putting an animation together like that with D3 and some of this off-the-shelf stuff would be very quick, like much faster than if you're like, all right, let me write a for loop to iterate over this data. Like, no. Hook it up to D3, you make some really cool stuff, like really cool looking stuff really fast. And so New York Times does this stuff a lot. That example that I showed there was like the New York Times visualization. So they use D3 and SVGs a lot to show these kinds of things because it's a very good way to go from data to cool looking stuff. And if that's the only thing you take away from this presentation, that's the important part, is like D3 plus SVGs equals data to cool stuff quickly. So browser support. So we're talking about basically putting SVGs directly in the DOM, in the browser. All modern browsers do it. And by modern browser, I mean IE 9 and above. If you've got to support IE 8, I feel for you just in general. And I haven't looked into this too closely. There's a project called R2D3 that claims to make it so that SVGs and D3 and everything will work in IE, like down to like IE 7. I wouldn't trust it. Like I would basically say like just avoid IE 8 if you can. So but the thing is, a lot of this stuff, like I say, is real cool stuff. So it comes down to how central it is to what you're doing. And so the New York Times is a very good example. Like the New York Times website is not made at the core with SVGs, but they'll have a special feature where they're like, let's examine Obama's budget. You click on that. If you're in IE 8, it says, I'm sorry, you don't get to see this one particular article. So like if you're at an organization or anything like that that has like these browser requirements and they say like, oh, well, we can't use D3 because it won't work in IE 8, the argument that I would make is let's just use it in places where it matters, like, or where we can use it quickly to do cool stuff. Like if you're building something that's like at the core, like you're building an analytics dashboard and all it is charts, like if you have to use IE 8, I would not use D3. But if you're trying to do one cool thing on your website or something like that, hey, if you're on IE 8, you don't get to see this cool thing. Upgrade, come see it. So that's my advice there. I talked a little bit about performance. The more stuff that you have on screen going on, the slower that your performance is going to be. And so it's not hardware accelerated. This is not what he was talking about, like with cubes rotating and stuff like that. If you're doing WebGL, 3D stuff, that actually uses your graphics card. If you're doing the animation that we're talking about with D3, it does not. This is sort of old school, old style animation of just like slowly moving something across a screen. So performance drops quickly as like your number of elements goes up. So if we think about this guy right here, like let's say that we want to click on one of these nodes and have it sort of position itself at the center and everybody else push themselves away. Like with all those, it'd be real slow and it'd be like real kind of jerky and the fans would spin up and it'd be going real fast. So, but the key is thinking in terms of like how can I scale down the number of elements that I've got on screen. So if we look at this guy, we've got all these individual nodes that then spiral out to other nodes. It's this big network thing. Why not get rid of some of the leaf nodes? Like, why not collapse that graph down so that you're not showing everything on it at once? So that's the key to like getting better performance through animations is like thinking in terms of like zooming. Like, I'm not going to show our birth rate example. I'm not going to. Maybe I have data for birth rates of every city in every country across the world. I'm not going to show all of that on the world map. But as I zoom in, and I zoom in on Central Africa, then I can start showing that data, and I can still have it animate nicely because what's on screen at any given time, I'm just reducing the number of elements that I have. So it's pretty standard optimization stuff. Like, just get rid of the data. Like, only show data that's relevant at that zoom level, and you can handle the performance problems quite a bit. Other ways to do it are like time slices. So, like, instead of showing like here's page views on my website for all time, I'm going to collapse that down to like, all right, I'm going to show it a month at a time. Like I'm going to time slice these things down. Again, it's all about cutting data down to a much more reduced like data set. So keep and the other one is if you can't do that, if you can't cut it down, maybe don't animate it. You know, a static image, you know, if you put 10,000 circles on the screen, the browser will actually render it. It's just that when you try to move those 10,000 circles around, that's when you get into trouble. So if you have to show a ton of data, don't animate it. You know, and if you have to change the data, like flash, then it shows the new data. Flash, then you know, not smoothly animating between them. So, so one thing about this presentation, the actual Smiler app that you were seeing there is backed by, and this is a little bit different. It's backed by a service called Firebase. And has anybody heard of it? Any thoughts on it? OK, so he's heard of it. So Firebase, this was an exercise for me in building an application that had no backend. There's no Ruby on Rails backend here. There's no PHP, nothing running on the backend. It's all JavaScript on the front end. And then Firebase is a sort of database as a service that sits on the back end and does real-time synchronization. So as you guys are voting, those votes go to Firebase. They don't go to my server. They go to Firebase. And then Firebase handles synchronizing that data. You know, as data comes in, it synchronizes it out to everybody else's client. So everybody's voting and has a vote count on their phone. I don't do that. Firebase does that. And I just wanted to say, like Firebase plus D3 is a great match. These sort of real-time back-end services, like PubNub, there's one called Parse. They're just these sort of like real-time data services that you push data to, and they handle synchronizing it out. Like D3 is made to handle data as it's coming in and changing. You know, this whole enter, update, exit stuff. So like you've got this real-time back-end that's, you know, collecting data. Maybe it's people like, you know, playing a game or something like that. Just you've got data coming into this back-end that you're synchronizing out. And then D3 handles in that update phase, like animating and changing things on screen. So I just wanted to say, like, D3 plus Firebase is a great match. This is a path. This is what I was saying, unintelligible. So what does this do? There. So that's a description of a heart. That's pretty much all I've got. By the way, those are SVGs. They scale up very nicely. Those all come from Pictonic. So yeah, you can find me on Twitter. I blog about a lot of this stuff, and then I also I co-host a podcast called Design versus Dev, where we talk about web development stuff from it's me and then a designer that I work with, and I tell him I can't make it look good, and he tells me I don't understand a thing you say. So and so we try to on the podcast we try to bridge those gaps. So any questions? Any thoughts?
You were talking about how setting up the scales. Could you just talk a little bit about kind of what that is? I mean, is it advanced math? Is it basic math?
No, and that's kind of the point. Give me a domain that you work in.
As far, I mean, just numbers versus time.
Data, yeah, data. Tell me some data that you would work with.
We work with a lot of admissions applications, so student data.
OK, so let's think of how would we visualize your student data? Like applications per hour or something like that.
Sure.
Like, which we would assume like in, you know, some off season is very low, and then boom, it's going to spike at some point. So like in that case, our scale, let's think about it. Our domain is sort of like number of applications. So yeah, our domain would be like number of applications. And so we would just set up the domain of that, which would be like 0 to, you know, and we'll think about it like on a day. So it'd be like 0 to, do you get like 100 a day? So our scale would be like 0 to 100. And our range, let's say we're gonna make a circle. So our range is the radius of the circle. And so the radius would be, you know, 0 to 300. You know, it's a 300 pixel radius circle. So then at this point, all you got to do is you got to chunk your data up into individual days. And one day is going to have 30 applications. One day is going to have 50. So it's very there's no math there. Like it handles calculating on a day that I get 50 applications, I need to draw a radius of a circle that's 150 pixels wide. Does that make sense?
Yeah.
So there are other scales. They're for like more advanced stuff, like exponential scales. You know, when you want the data, like sometimes you need like an exponential scale to show like this day we get 10 applications, this day we get 100, this day we get 20,000. So you can't, you know, you can't show a chart that like just goes way off the chart, so you have an exponential scale. And it'll handle building exponential scales and logarithmic scales and that sort of thing as well. So you can also have, I think they're called ordinal scales, where you basically, this is going to sound like I'm smart, but I'm not. So with a linear scale, it's continuous, and so you've got continuous values from the bottom to the top of your scale. With an ordinate scale, it's discrete. So you'd say like very discrete individual points on that scale. I want to map them to, and so a good one of those would be months. Like months are very discrete. You don't have like January and a half. So you can map things to, I want to map these elements individually to these ordinal elements, so to January to February. So that's where ordinal scales come in. I think somebody else had a question.
For absolute beginner, let's say for example, I have a website and I've been searching for a really nice front end for some analytics. I want to show back to users.
Okay.
Meaning, like, I don't want to have it on a side or buried somewhere. I want users to be able to see kind of, and not even really in real time, just what's going on with the site. And I think D3 would be great because I really want to make it kind of fun and not pie charts, But I have no idea where to start or how to start.
It's going to be tough. It's going to be tough because it's some advanced JavaScript. As the expectation is that you understand JavaScript well. The expectation is that you understand the DOM and HTML very well, and the expectation is that you understand SVGs to a certain extent.
So I got HTML and SVGs.
Okay.
And I already have an analytics engine. And it's like WordPress based, so it's giving me shortcuts. So I can access the data, know where the database is.
It's, well, and what I'm saying is until something like, what do we got? Yeah, until something like this, or where's it more complicated? Yeah, this guy. Until you can look at something like this, and you don't have to understand every bit of it. There will get to be a point where you can sort of like go to Stack Overflow and copy and paste it in, and sort of it's often called cargo culting, which has a real bad connotation, but I actually don't think it's such a bad thing, especially for people that are new. So you're gonna have to get to a point where you can cargo cult something like this into your code and like make a few changes and be like, I don't understand exactly what's going on here, but it's a pretty steep mountain to climb to get there.
So there's this kind of port of D3 called D3.js. Have you heard of this?
There's a lot of stuff, yeah.
So basically D3 is awesome, but it is super verbose, and it's really hard, like you say, it's really hard to kind of grok very quickly if you don't love JavaScript. But like C3, and I'm sure there are other ones, but like it kind of takes and wraps up really common usages of D3 into much simpler ways that you can kind of just write more basic JavaScript and then get a ton of like pre-configured graphs and other layouts and stuff like that. And I found it's like a really good way to kind of get into it, because if you want to expand, you can kind of break it out back into the the D3 language and get more fancy, but it lets you kind of utilize all of what he's talking about without having to learn all of that stuff.
And he makes a good point. There's a lot of stuff out there for D3 sort of built on top of it. Another example is a thing called NVD3, which is a charting library for making bar charts, line charts, that sort of stuff. But it uses D3 under the hood, and so it's sort of a good way, again, like to sort of dip your toes into it and be like, I'm going to get this working with NVD3. It's going to be some boring-ish charts, but later on, as I understand more and more, I can go through and actually edit this and start to look under the covers as to how this stuff is working and start messing around with it some more. Thank you. That was a very good. That was a very good point.
Can you define your own scale functions? Like, or does it just generate a scale linearly or logarithmically or exponentially or ordinally, depending on just what numbers you pass to it and whatever?
What would you want? The answer is probably yes, and I don't know how to do it. But what would you want in like defining your own scale function? Like what are the inputs? What are the outputs? What do you expect?
Maybe I'm not thinking about it. Maybe I just take the scale and then run the function on the scale, so that you could like maybe make like a sine curve or something. You know what I'm saying?
I think I see what you're saying. Like there are ways to do that kind of stuff. Like, and it's, yeah, a lot of times it's more of just like, looking at the tools that you've got and being like, I don't understand, and then All right, we're out of time. OK. Thanks, everybody. I'll be walking around.